Imagine a world where designers no longer struggle with repetitive tasks and inspiration flows effortlessly. This is the promise of generative adversarial networks, or GANs. I'm Priscilla Anthonio Kurniawan, and today we'll uncover what drives GAN adoption among designers in Indonesia's creative industry. Generative adversarial networks, or GANs, are a type of deep neural network that have revolutionized creative industries. They allow designers to automate repetitive tasks, generate novel content, and enhance efficiency. However, despite their potential, the adoption of guns in design processes remains a challenge. Designers often struggle with understanding the technology's capabilities and accepting its integration into their work. Moreover, previous studies have primarily focused on the technical aspects of guns rather than the barriers designers face during adoption. Therefore, this study aims to explore the factors influencing the adoption of GANs in design processes. Specifically, examine the factors shaping a designer's intention to adopt GANs, identify challenges in adoption and understanding of GANs, and to provide actionable recommendations for stakeholders to integrate GANs effectively into creative workflows.
The research model was constructed from prior research to align with the goals and hypotheses of our study. And from the model, we drew out its hypothesis to understand the factors that impact users to adopt GAN technology in design processes. This study used a quantitative method through a questionnaire consisting of 32 items. Individuals from a wide array of design sectors in Indonesia took part in this study, and 376 valid responses were received. Furthermore, the data analysis was performed using PLS-SAM with Spark PLS as the primary statistical software. After collecting the data, we conducted validity and reliability tests to confirm that the indicators effectively measure the construct they are intended to represent. All indicators were deemed valid and reliable as autoloading, FVE, and CM values are exceed the certain thresholds. Next, discriminant validity was assessed using the HT-MT ratio method to confirm that the constructs are distinct and exhibit minimal overlap. Discriminant validity is well established in this study as all construct values are less than the established threshold.
Lastly, we have conducted hypothesis testing in which from 8 hypotheses that we propose, 4 are rejected while the other 4 are accepted. Let's conclude with the key takeaways from this study. Firstly, GAN proves to be a powerful tool in the design process. By automating repetitive tasks, it not only reduces workloads but also increases productivity and also enhance the overall quality of the creative works. Secondly, technology adoption among designers, especially Gen Z, is heavily influenced by social trends, community interactions, and the enjoyment they feel when using a certain technology. This highlights the importance of creating a sense of connections and fun around GAN adoption. Lastly, the study provides insights to develop strategies for GAN adoptions by emphasizing social influence, building self-efficacy, and creating enjoyable user experience. One limitation from this study is the sample selection, which may not fully represent the general population, as most of the respondents are female and from Java Island. Therefore, future research should aim for a more balanced regional and gender representation. Additionally, the reliance on self-supported data could introduce the response bias. By that, future study could adopt the qualitative or mixed method approaches to gain deeper insights and mitigate these biases. As Bill Green wisely said, if you are not investing in a new technology, you are going to be left behind. The adoption of GAN is a crucial step towards innovation. Embracing this technology will enhance workflows and put designers at the forefront of the future. Let's invest in the transformative potential of GANs to reshape designs.